Alright, you guys, this is mainly for period 1. We are looking at section 5 and chapter 7. Alright, so what we're going to do is we are going to look to solve these exponential equations. Now there's two different methods. The first method is when you're solving an exponential equation that has the same base. So if you look in the first example here, we don't actually have the same base. We have 16 and we have 8 as our bases, but we could rewrite each of them so we do have a common base. And that's going to be our first step. So rewrite each side with a common base. So I know 16 is really 2 to the power of 4. So I can rewrite it like that. And I'm going to bring down the exponent of 3x. Also, I know 8 is really 2 to the power of 3. So now I do have a common base. My next step is to use the power property of exponents. The power property just says that if you have a power raised to a power, that you are going to multiply. So now I have 2 to the power of 12x is equal to 2 to the power of 3. If you have the same base, then you're allowed to ignore the bases and set their exponents equal to each other. So basically, I'm going to cross out these bases, and I'm going to say 12x, since that was the exponent, is equal to 3, since that was the exponent. And my final step is just to solve for the variable. So to isolate x, I'm going to divide by 12 on each side, and then reducing that, x is going to equal 1 over 4. And this is my answer. These are great types of problems because you can always check your answer by plugging in 1/4 to the x up here, saying 3 times 1/4, and then raising 16 to that power. And if it equals 8, then you know you did it correctly. Alright, looking at this next example, I want to follow the same directions as before, which were first to find a common base. So 3 is already a prime number, so I can't rewrite that. But 27 is really 3 to the power of 3. So I'll rewrite 27 as 3 cubed, and that's still being raised to the power of 2x. The next step was to apply the power property of exponents. So 3 to the power of 3 to the power of 2x is really 3 to the power of 6x, since they multiply. And on the left, it's still 3 to the power of x plus 2. Now that we have the same base, we can just set our exponents equal to each other. So I'm going to ignore the bases and say x plus 2 is equal to 6x. And now I just need to solve for the variable. So I'm going to go ahead and bring my x's together. I'm going to subtract x on each side. So I'll get 2 is equal to 5x. And then solving for x, I'm going to divide by 5. So x is equal to 2/5. And again, if you wanted to, you could plug this into your calculator. You'd have to substitute 2/5 for the x on this side and the x on this side, and then see does this value equal this value. If you have a true statement, then you have the right answer. Alright, so I want you to try these two problems. I'm going to put the answers up in just a moment. If you want to, you could try these problems down below also, and I'm going to put the answers up also for these. Remember, you have your homework in the workbook, so this is not for homework right here. It's just to make sure that you're doing it correctly. Alright, sorry about that. Again, try all of these problems and then check your answers. Make sure you got them right before you do the homework, because then otherwise you'll be doing the homework all wrong. Okay, for the first you try, x is equal to 4/9. For the second you try, x is equal to 4/5. For the practice problems, number 1, x is equal to 3. Number 2, x is equal to 3 halves. Number 3, x is equal to 1. And number 4, x is equal to -1. So hopefully you got all those right. And let's continue on. So we're still solving exponential equations, but now we're looking at different types of problems. So in this example, we have 15 to the power of 3x is equal to 285. Now, 15, it can't be broken down. It's no number raised to a power gives us 15. Not a whole number anyways. And then we know 15 squared is 225, but we need 285. And 15 cubed is way too much. So we're not able to get the same base. So the method that we're about to apply is when we have different bases. All right, so when you have different bases, that's when you're going to use this method. Now, yes, you could use this method even if you have the same base. So if you're just not very good at determining how to change the base, like if you're not aware that 2 to the power of 6 gives you 64, or 4 to the power of 3 gives you 64, if you're not very good at that, then you would probably want to use this method that we're about to use for all these types of problems. And that's fine. So step 1, we're going to take the log of base 10 of each side. So in this first example, all that means is we're going to write the word log in front of each side. So log of 15 to the power of 3x is equal to log of 285. Step 2, we're going to use the power property of logarithms. So we have this power of 3x, and we know that the power property tells us to put that in front. So 3x times log of 15 is equal to log of 285. Now to solve for x, which is our last step, so our last step is to isolate the variable. You have to look at x and you realize that x is being multiplied with the 3 and it's being multiplied with the log of 15. So to undo multiplication, you're going to divide by 3 and divide by log of 15. So on each side, I'm going to divide by 3 because that'll cancel out the 3. And I'm going to divide by log of 15 because that'll cancel out the log of 15. And I'll be left with just x. And now plugging this into my calculator, and you need to be careful. You want to make sure that you apply parentheses where necessary. So if your calculator opens up parentheses right here, you need to close them. And then if you're using a division sign, you need to make sure that you open parentheses right before the 3. And again, if it opens it here, you need to close it and then close the parenthesis that you had opened by the 3. So rounding to the nearest thousandths, we're going to get x is approximately 0.696. So again, if you're not getting that in your calculator, you want to double check all your parentheses. All right, let's look at the next example. All right, and actually instead of me doing this example, we'll make this the you try one, YT you try. And I'm going to do this you try over here as my example. So the first step was to take the log of each side. So log of 25 to the power of 2x plus 1 is equal to log of 144. All right, using the power property of logarithms, I'm going to bring this quantity 2x plus 1. I'm going to place it in front of the log of 25. Now because they're multiplying together, I need to put parentheses around this expression. And then it's equal to log of 144. Now to isolate my variable here, it's going to take a few steps. The first step is dividing. So I'm going to divide by log of 25. and that'll cancel out the log of 25. And so I get 2x plus 1 is equal to log of 144 over log of 25. Now to solve for x, I have two things I need to do. First is I need to subtract 1, so minus 1, and that's going to cancel out this, and I'll get 2x is equal to log of 144 divided by log of 25 minus 1, and then to isolate x all the way, I need to divide by 2 on each side. So in your calculator, all of this, okay, so like I was saying, all of this you're going to have to divide by 2. So you're going to put this in your calculator, say enter, and then say divide by 2. In rounding to the nearest thousands place, x will be approximately 0.272. Alright, so again, I want you to try this, you try up here. I want you to try this, you try right here, and these 4 problems. So pause it because I'm going to post the answers so you can make sure that you got the hang of it before you try your homework. Alright, so the first you try, x is equal to, or approximately 1.512. In the second you try, x, or y actually, y is approximately 3.644. And then in the practice problems, x is approximately 1.585. X is 3. Y is approximately 0.953. And x is approximately 2.107. Alright, so like I said, hopefully you got these right. If not, you should go back and just make sure you have entered it into your calculator correctly. Alright, so try the homework. Again, the homework is in the workbook on page 203, and it's problems 1 through 12. Alright, see you Monday.